Concrete has long been the foundation of modern civilization, from the bridges we cross to the buildings we live and work in. However, as our infrastructure ages, the challenges of maintaining and rehabilitating concrete structures become increasingly critical. Today, we are here to explore the transformative potential of the future concrete rehabilitation program, an innovative approach that addresses these challenges with cutting-edge technologies and sustainable solutions. So why is this important? So concrete infrastructure represents a significant investment of resources and energy, allowing the structures to deteriorate not only poses safety risks, but also has a profound impact on the environment. So current repair methods are often costly, labor intensive and environmental damaging. A revolutionary change is needed to ensure our infrastructure stands the test of time while aligning with global sustainability goals. So in this presentation, we will cover 3 groundbreaking advancements in the field of concrete rehabilitation. So the first one is self-healing concrete technology, which repairs itself without human intervention. The second one is advanced sensor integration, which enabling real-time monitoring of structural health. And the last one is eco-friendly rehabilitation materials, which designed to reduce the carbon footprint of concrete repair processes. So we will also discuss the societal and environmental consequences of adopting these technologies and how they align with the Sustainable Development Goal 9, which is industry, innovation and infrastructure. So let's get started by delivering into the first revolutionary innovation, which is self-healing concrete.
Okay, for self-healing concrete, for the introduction, self-healing concrete is a revolutionary technology that repairs cracks automatically, reducing maintenance costs and prolonging the lifespan of structures. As for the key innovation components, use of bacteria or chemical agents that activate when cracks form in the concrete. Okay, as for number 1, microbial healing agent, as known as bacterial-based approach. When crack forms and water seeps in, the bacteria are activated, consuming the calcium lactate to produce calcium carbonate, which is limestone, which will fill the cracks. The advantages of this method: it can completely natural process, prolong functionality as the bacteria can remain dormant for decades until activated. As for number 2, capsule-based healing system. How is this work? Is when tiny capsule filled with healing agents like epoxy, and when cracks form, the capsule breaks open, releasing the agent which react with water and other compounds to seal the cracks. The advantages of this method: it is very precise, localized crack repair. It is also no need for manual application of material repair. Why these innovations are significant? As for number 1, it is cost saving, reduce the needs for manual intervention, inspection and frequent repairs. For number 2, enhanced durability, prevent minor cracks from growing into major structural issues. Number 3, sustainability, which can reduce resource consumption by extending the lifespan of concrete structures. And lastly, for environmental benefit, this method can minimize the concrete waste and also reducing carbon emission from repair activities. That's all from me. Let's move on to the next speaker.
Let's now discuss how advanced sensor integration is revolutionizing the future of concrete rehabilitation. Smart sensor embedded into concrete structure enable real-time monitoring the critical parameters such as stress, temperature, and overall structural health. This technology provides engineers with invaluable data to ensure the reliability and safety of our infrastructure. How do these sensors work? They use load-based system to detect issues at an early stage before visible signs of damage appear. By identify problems early, predictive maintenance become possible, significantly reducing the need for costly and invasive repairs. These sensors are particularly beneficial in high-risk areas such as earthquake-prone regions, where early detection of stress point could prevent structural failure. The impact of advanced sensor integration of society. In summary, advanced sensors are not just tools, they are the foundation of the smarter and safer futures for our infrastructure. Thank you, and let's move on the other next speaker.
Okay, today I will talk about how sustainability materials in rehabilitation ensure minimal environmental impact, focusing on green concrete technology. Green concrete technology use recycled material like fly ash, recycled aggregate, and geopolymer concrete. This reduces the need for natural resources and cut carbon emissions during production. Carbon capture technologies in concrete further enhance its environmental benefits. In rehabilitation project, green concrete promotes a circular economy by reusing demolition waste as a raw material. This reduces landfill use, lowers the carbon footprint, and conserves resources. By adopting green concrete, we are not just restoring structure but also reducing environmental harm and moving to sustainable construction practice. Let's move to the other speakers.
I will present about collaborative implementation and future vision. Firstly, need for updated construction codes and policy. Policymaker may implement codes that support the integration of smart building technologies such as IoT, automated system, and advanced energy management. Secondly, training program for engineer and contractor. Engineers should participate in structure professional development courses to stay updated on new materials, technology, and best practices. This course could be delivered through workshops, online platform, or university partnership. Policymaker can incentivize engineer and contractor to participate in ongoing education by offering tax benefit, subsidy, or professional development hours for attending accredited training programs. Third, case study of successful projects using future rehabilitation by our researcher in university and industry. On future vision, hopes infrastructure is far more advanced than today, capable of self-repair, environmental adaptation, and long-lasting durability. Imagine a world where our infrastructure repair itself, adapt to environmental conditions, and last for generations.
So to conclude, the Future Concrete Rehabilitation Program provides an innovative and sustainable path forward for maintaining and strengthening our critical infrastructure, from self-healing concrete to advanced sensor and eco-friendly materials. This advancement promise a future where our infrastructure is not only more resilient but also more environmentally responsible. So we must embrace these innovations and collaborate as engineers, researchers, policymakers, and stakeholders to turn this vision into reality. So the future of construction is not just about building better, but about building smarter and greener. So let's work together to ensure a sustainable and safe future for generations to come.